Yesterday, we had discussed the general heat conduction equation in Cartesian coordinate. As I said, we want to derive or we want to study the three mode or three coordinates, the equation, the general heat conduction equation in three coordinates, which is Cartesian coordinate, cylindrical coordinate, and spherical coordinate. So, yesterday we had already discussed about general heat conduction equation in Cartesian coordinate. So, today we want to discuss about the heat conduction equation cylindrical coordinate. So before that, I'm just rewinding the derivation that we have studied yesterday. So as I said that here we are finding the net heat accumulated in the element due to the different direction x-axis, y-axis, and z-axis, which means A. The total derivation is termed as A plus B equal to C. This is what we want to find, A plus B equal to C. A is defined as the net heat accumulated in the element due to conduction of heat from all the coordinate direction, uh, which is given as A here, A, and plus the heat generated within the element. Within the element is B, and equal to C, energy stored in the element. So for this derivation, I have already referred the three elements, which is Qg. Here it is Qg. It is termed as heat generated per unit volume per unit time. Now capital letter Qg, capital letter Q equal to maximum and total energy stored in the whole element. But Q, small letter Qg is the heat generated per unit volume per unit time. It is a small rate of change of heat. So rho as density, mass density of material, and C as specific heat of the material. This is, we are taking the three terms Qg, rho, and C for the three derivations. Okay, the mode of derivations for the three derivation is identical. For the three derivations, we are doing a simple and very light derivation like A plus B equal to C. We want to find the net heat accumulated in the element due to coordinate axis to three axis as A for the three derivation plus B heat generated within the element and energy stored in the element C. We are doing the same method for the three derivations. So for that, first of all, we considered an element, an axis, like x-axis, when we have already derived the derivation. So I am not explaining the derivation here. Just looking after what we have studied. Okay, we have studied. I already studied the heat generated in x direction, and of course for y and z direction. And we have summation. We together we will get the a term, that is net heat accumulated in the element due to conduction of heat from all direction x axis, y axis, and z axis. Like that, for the second B, we have derived that Q dash G equal to Qg into dx dy dz. Now let's look at dx dy dz. Dx dy dz is the volume of the element that we have taken. Dx is one side, dz is another side, and dy is the height of the material we have taken, that is cuboid. So dx dy dz is the volume of the element what we have taken. So here we are taking Qz, B part. In B part we are taking Q as Qg equal to Qg small letter Qg into dx dy dz d2, which means that dz dx dy dz is the volume of the element. Like that, in the same, in cylindrical coordinate we are taking the volume of the element as, and that here dx dy dz is for cylindrical coordinate we have we are not familiar with the x-axis, y-axis, and z-axis in cylindrical coordinate. There is no something like that. There is no perpendicular axis for cylindrical coordinate. Just because I will show you that for x-axis, y-axis, z-axis we are taking perpendicular axis x, y, and z. And for cylindrical coordinate, this is the figure that we want discussing for cylindrical coordinate. This is a cylindrical coordinate. There is no perfect 90-degree axis for x, y, and z. Here that figure we are taking here, the small figure we are taking here, it is in the cylindrical coordinate. There is no dx, there is no dy, and there is no dz. Simply there is dz is there because it is aligned in the z axis. It is aligned in the z axis, so dz will be there, but there is no dy or dx. Instead, we have dr and term d phi is there, right? There is some angle difference between the uh, axis x and y. It is aligned in the some angle phi. Therefore, d phi is the angular distance, and the r is the radius that the cylindrical coordinate together make with the axis. So we have r as the radius from the axis, and d phi is the elemental area. For together we are taking here r dr r phi. Just make a look for cylindrical coordinate in the PPT. For cylindrical coordinate, this is a equation for cylindrical coordinate. So we are taking the figure as like that we have seen and just before. Here there is a distance of radial distance r is there, and the angular distance is d phi. So the total the distance of the particular radial side is r d phi. R d phi here. R d phi is shown here. Sorry, I'm taking pen. Okay, r d phi is there, and dz is there. One side is dz and one side is r d phi, and one is dr, radial distance. Dr in the direction of radial distance r, and d phi some angle or distance traveled by the material phi. So the together the radius become, the side become r d phi and dr. So together the volume of the element is like is in Cartesian we get that dz dx dy dn dz. Here it is dr dz and r d phi. Okay, here it is from the volume of the element. We are starting with the volume. Volume of the element is r d phi dr dz. Okay, r d phi dr and dz. So further, let us assume that k is thermal conductivity, rho is density, c is specific heat, as like a Cartesian coordinate. Okay, so here the volume is r d phi dr and dz. There is no x-axis, y-axis, and there is z-axis. That it is aligned in z-axis, but there is no dz and dx, because it is not like a cuboid. It is like a cylindrical shape that we are cut, and we are taking a section for analysis. Okay, so we want to find A, B, and C like in previous derivation. So first A is the net heat accumulated in the element due to conduction of heat from the all coordinate direction, like x-axis, y-axis, and z-axis. Here it is planes. Heat flow in a x5 plane, xz plane, sorry, x5 plane. The element is denoted, or it is referred in a xz plane in the direction of r. So here for Cartesian coordinate we have taken the area. We are starting with the equation that if we have studied for Fourier law, that is q equal to minus k into a into dt by dx. Okay, here we are taking xz plane first. For heat influx or heat input into that plane is minus k into a into dt by dx. What you have studied in the Fourier law. Here the area minus k is the area is r d phi dz. അതങ്ങനെ വന്നതെന്ന് വെച്ചാൽ കഴിഞ്ഞ ഡെറിവേഷനിൽ പഠിച്ചു എക്സിന്റെ കാര്യം ഡിനോട്ട് ചെയ്യുമ്പോൾ നമ്മൾ ഏരിയ എടുത്തത് y z ആയിരുന്നു അല്ലേ. ഫോർ എക്സ് ആക്സിസ് വി ആർ ടേക്കൺ ഫോർ എക്സിന്റെ കാര്യം ഡീൽ ചെയ്യുമ്പോൾ നമ്മൾ എടുത്തത് dy dz ആണ്. ഹിയർ dy dz, and for y we have taken dx dy, and for z we have taken dx dy. Okay, like that. Here we are taking, first we are considering the qr, it means defined by dr. So we are taking the other two sides as the area. So qr equal to minus k into r d phi, that is one side, and dz into dou t by dou r into d tau, like in previous example. So heat efflux, that means heat is leaving, the leaving heat is defined as qr plus dr. It is qr plus, that is some entering plus a fraction of entering. പറഞ്ഞു എൻ്റർ ചെയ്ത് ഒരു ഡിസ്റ്റൻസ് ട്രാവൽ ചെയ്തിട്ടാണ് പുറത്തേക്ക് പോകുന്നത്. എൻ്റർ ചെയ്യുന്ന ടെമ്പറേച്ചർ പ്ലസ് ആ ട്രാവൽ ചെയ്യുന്ന സ്ഥലത്തുള്ള എനർജി കൂടി ഒരുമിച്ച് കൂടിയിട്ടാണ് പുറത്തേക്ക് പോകുന്നത്. ട്രാവൽ ചെയ്യുമ്പോൾ കുറച്ച് കുറയും. എത്രയാണ് കുറയുന്നതെന്ന് വെച്ചാൽ അത് നമ്മൾ ഡിഫറൻഷിയേറ്റ് ചെയ്യും. ഓക്കെ, സോ ഹീറ്റ് ഇൻഫ്ലക്സ് ഈസ് ദി എഫ്ലക്സ് ഈസ് ദി ക്യു ആർ പ്ലസ് എ ഫ്രാക്ഷൻ ഡോ ബൈ ഡോ ആർ ഓഫ് ക്യു ആർ, ഡോ ബൈ ഡോ ആർ ഓഫ് ക്യു ആർ ഡി ആർ. ദിസ് ഈസ് ദി ഹീറ്റ് എഫ്ലക്സ്. So heat accumulation and the element due to heat flow in that direction will be equal to heat influx minus heat efflux, heat input minus heat output. So here that is qr minus q dash of r minus q dash of r plus dr. It means that heat influx minus heat efflux. So qr minus qr plus dr. So qr and qr get cancelled. qr minus this term, right? qr minus qr and qr minus qr cancelled. The term that will get is negative of this minus. Right? Okay, let us make a look. qr minus qr dash plus dou by dou r of qr, right? There is a bracket here. So negative term will be entering here and here. So when it is get cancelled, the term that you will get is negative of dou by dou r of qr, this term. Okay, so we know that qr dash is, substitute qr dash from here to here, qr dash dou by dou r of the, you can write the same term here, minus k into r minus k into r d phi dz dou t by dou r into d tau, and here dr is the here. Okay, so let us expand it. നമ്മളെന്താ ചെയ്യുന്നത് വെച്ചാൽ 3 ഡെറിവേഷൻ ചെയ്യുന്നത്. വോളിയം, അതിൻ്റെ വോളിയം പുറത്തേക്ക് എടുക്കുകയാണ് ഇൻറ്റു കെ. 3 ഡെറിവേഷൻ മാക്സിമം വി ആർ ടേക്കിംഗ് ദ നെറ്റ് വോളിയം ഇൻറ്റു കെ ആസ് ഔട്ട് സൈഡ്. ഓക്കെ, എന്തിനാണ് ഔട്ട് സൈഡ് എടുക്കുന്നത് വെച്ചാൽ ലാസ്റ്റ് ക്യാൻസലായി പോകാൻ വേണ്ടിയിട്ടാണ് ഔട്ട് സൈഡ് എടുക്കുന്നത്. സോ എങ്ങനെ വന്നാലും അതിൻ്റെ വോളിയമാണ് പുറത്തേക്ക് വേണ്ടത്. ഓക്കെ, so negative dou by dou of k into r d phi dz into dou t by dou r into d tau. This is term you have got. So just we want to take the volume of the element to outside. It's what the volume is r d phi dr dz, right? Here volume of the element is r d phi dr dz. ഇതിൽ അങ്ങനെ ഒരു ടേം എന്തായാലും ഉണ്ടാവും, അതെന്തായാലും പുറത്തേക്ക് എടുക്കുക. ഇല്ലെങ്കിൽ അങ്ങനെ ഒരു ടേം ഉണ്ടാക്കുക by adding and multiplying. So multiplying dividing the numerator to denominator. So here k is there, r d phi is there, dr is there. Okay, so we are taking k into dr into d phi into dz, dr into d phi into dz outside, and the term available is dou by dou r into r. R is the r into dou t by dou r into d tau. We are taking dou by dou t into dou by dou t into dou by dou r into d tau. So the what is the volume, right? R d phi into dr dz. Okay, here r is not the, okay, here r is not the, only dr d phi dz is the. R is here, but this is inside the bracket, right? With the derivative form. So this is a derivative equation. What we have studied first, we have studied that derivative of an element, that multiple element x into y equal to first derivative of second plus second derivative of first, right? First derivative of second plus second derivative. So like that we are differentiating this term as first derivative of second, r into d square t by dr square, that is derivative of second, plus second into derivative of first. Second is dou t by dou r into derivative of first with respect to dr. With respect to dr, the term r will become 1. dx d by dx of x equal to 1. Okay, so we are expanding this bracket, right? R into dou square t by dou r square plus dou t by dou r into d tau. Like we are differentiating this term and writing the simply as k into dr d phi dz into the negative and negative term is already cancelled, right? So the remaining term will be r into dou square t by dou r square plus dou t by dou r into dr. So here take r as outside. take r outside here. So dr into r d phi into dz. R is taking outside. So the remaining term, when the r is taking outside, and this is two term, the r is, when we cannot take r from the bracket unless it is multiply or divided by the next term, right? R ഒന്ന് പുറത്തെടുക്കുമ്പോൾ ഇവിടെ എന്താവും, ഡിവൈഡ് ചെയ്യാണ്, പുറത്തേക്ക് എടുക്കുമ്പോൾ ഇവിടെ 1/r വരും അല്ലേ. So dou square t by dou r square plus 1/r into dou t by dou r is the remaining term. Okay, k into d, we have taken the volume as outside and the remaining term is the right. This is the heat flow for only one direction, that is x5 direction. So like that we are doing the 3 direction. Okay, so next one is heat flow in a tangential direction rz plane. Rz plane, that is in the 5 direction. U dash of phi equal to minus k into next two term dr into dz. Like we are taking here phi and we are taking the next two direction, next to thickness for deriving the area. This is area, minus k into a into dt by x, like that. Here we are taking minus k into dr dz into dou t by r dou phi. Here for r we are taking dou t by dou r. For ആ ഡയറക്ഷനിലെ ആ തിക്നെസ് ആണ് എടുക്കുന്നത്. ഡോ ടി ബൈ ഡോ ആർ എന്ന് പറഞ്ഞാൽ ആ സൈഡിലെ തിക്നെസ് ആണ്, ആറിന്റെ സൈഡിൽ തിക്നെസ് ആണ് ഡോ ആർ. സോ ഹിയർ ഫോർ ഫൈ ദ തിക്നെസ് ഈസ് ആർ ഡോ ഫൈ, റൈറ്റ്? So minus k into dr dz into dou t by r dou phi d tau. So like the heat efflux is the heat input plus some derivative of this input, dou y r dou phi of qz. So net heat accumulated in element due to flow of tangent direction is 1 minus 2 heat influx minus heat efflux. Like the same method we are doing for 3 axis. So from subtracting 2 from 1, we will get dq dash of phi equal to q dash of phi minus that term, the second term. What is second term? Here it is q dash of x minus q dash of phi minus q dash of phi plus dou by r dou phi of q dash of phi, right? So it is in bracket. For we are applying negative into inside the bracket, hence the q phi and minus q phi cancel. Then the remaining term will be minus of dou by r dou phi into q dash of phi, right? So the remaining term will be negative of minus r dou phi into q dash of q of phi r d phi. This q dash of phi star, okay, q dash of phi r dou phi. So substitute for q dash of phi, that is, what is q dash of phi here? We have taken minus k into dr dz of dou t by r dou phi, right? So substitute in the q dash of phi here, minus k of dr dz into dou t by r dou phi into d tau, okay, d tau into r d phi. That is the simply this term, r d phi is coming. Okay, now what we want to do is the same method I have applied earlier, that take the volume of the element outside. Take the volume of the element outside. Here k volume of the element into k outside. So we are taking k dr dz and there is a dou phi. We cannot take r here because here there is a r and here there is an r. The r and r get cancelled from this step. R and r get cancelled from this step. The element available is k into dr dz into d phi only. So k into dr dz into d phi we have taken outside. Then the remaining term will be dou by dou phi of, here there is an r, 1 by r dou t by dou phi into d tau. Okay, here r and r gets cancelled. So we want an r here, right? We want an r dou phi. We want an r here. So what to do to place an r here? Multiply and divide an r in this equation. Here we want to apply r and divide by r by r. So there is an r, we will get in numerator and there is an r in denominator. So that is what we have done in this step, is multiply and divide by r. So we get an r from here. So k into dr into r d phi into dz. By dividing the r, the 1 by r will become r square, 1 by r square. and the dou by dou phi into dou t by dou phi will become dou square t by dou phi square. Okay, dou square t by the 1 by r is taken outside and dou by dou phi is inserting here and it become dou square t by dou phi square. Okay, 1 by r square into dou square t by dou phi square into d tau. Okay, this is the second direction. This is a heat flow from the second direction. We had completed 1 and 2 direction. For next, the plane we are considering is R5 plane. R5 plane. We have already described Z X plane and X Z plane. Here and here R5 plane. R5 plane. For R5 plane, we are designing the Z. We have R, phi and Z here. First for R, we have taken as Q and Z as the area. For phi, we have taken R and Z as the area here, dr dz. And for Z axis, we are taking the next two thickness as area. The next two thickness is R d phi and dr. Right? So heat influx is Q dash of Z equal to minus K A d dt by dx, like we studied in the Fourier law. Here it is Q dash of x equal to minus K into that area, that is R d phi and dr, which is the next two thickness. And here dou t by dou z is the for z, it will become dou z. For phi, it is become that thickness, that is R dou phi. Here the thickness is dou z for z. For taking negative K into R d phi dr in dou t by dou z into d tau. For heat efflux is the input plus some derivative of the input. So Q dash of z plus dou by dou z of Q dash of z is the, okay, heat equivalent element direction is become the heat influx minus heat efflux, that is Q dash of z minus Q dash of z plus dou by dou z of Q dash of z. Okay, that is again it is in bracket. So we apply the negative sign inside the bracket, we will get the Q dash and Q dash z get cancelled, and the remaining term will be negative of dou by dou z of Q dash of z. Here the remaining term will be negative of dou by dou z of, that is not included here. Negative dou by dou z of Q dash of z will be there, and dz is there. This is there in the here. So by substituting Q dash of z from here, Q dash of z is negative K into R d phi dr into, that is shown here. This step has been skipped here. So let us so negative of dou by dou z of, here Qz is substituted, negative K into R d phi dr into dou t by dou z into d tau into dz. Okay. So here also we want to take the volume of the element outside. So look what we have here. K is there. Okay. R d phi is there, dr is there, and dz is there. For every element is here itself. K is there, R d phi is there, dr is there, and dz is there. Okay. Take over the term outside that we have need, that is volume, into K. K into dr, R d phi into dz taken outside, and the term available remaining is the negative and negative term gets cancelled. Okay, so dou by dou z into dou t by dou z, that is dou square t by dou z square, dou square t by dou z square, multiplying this used term, and dou t will be also there. Okay, so the volume it has taken, and the other term here is dou square t by dou z square. So we have completed the heat equation of the conduction or heat transfer from the three axis. That is, we had already found the equation for the three. Together, the three, 1 plus 2 plus 3, together constituting the A term, right? Together constitute the A term. കാർട്ടീഷ്യൻ കോർഡിനേറ്റ് നമ്മൾ അങ്ങനെ ചെയ്യേണ്ടി വന്നില്ല, കാരണം എക്സ് എക്സിൽ മാത്രം കണ്ടുപിടിച്ചിട്ട് നമ്മൾ വൈന് സെല്ലിനും ഇക്വേഷനിൽ എക്സിന് പകരം വൈ കൊടുത്തു, എക്സിന് പകരം സെറ്റ് കൊടുത്തു, അങ്ങനെയാണ് നമ്മൾ കിട്ടിയത്. പക്ഷേ ഇവിടെ സിലിണ്ടറിക്കൽ കോർഡിനേറ്റ് അതൊരു പർട്ടിക്കുലർ ലൈൻ കോർഡിനേറ്റ് ആയതുകൊണ്ട്, ഒരു പെർട്ടിക്കുലർ പ്ലെയിനിൽ നിൽക്കുന്ന കോർഡിനേറ്റ് അല്ല, അതൊരു ഏരിയയിൽ ഒരു വോളിയത്തിൽ എയറിൽ നിൽക്കുന്ന കോർഡിനേറ്റ് ആയതുകൊണ്ട് തന്നെ ഒരു ആംഗുലർ ഡിസ്റ്റൻസ് ആണ് ഉണ്ടാകുന്നത്. അതുകൊണ്ട് അതൊരിക്കലും മൂന്ന് വേറെ കണ്ടുപിടിക്കണം. ഓക്കെ, റൈറ്റ്. Okay, so the net heat element in the both three axes, the summation of the both 1 plus 2 plus 3. The common term in the three equation is the volume into K, that is dr, d5 and dz into K. So together we can take that common term outside. So here they are skipped that the step that the summation of the three separate, and they are taken the common term as outside, that is k into dr d5 dz, that is the volume into K is taken outside, and the term additionally came here, or remaining term will be the remaining term of the first equation plus remaining term of the second equation plus remaining of the third equation. That is, for first equation we have the remaining term will, that is dou square t, here dou square t plus 1 by r into dou t by dou r. Okay, dou square t plus 1 by r into dou t by dou r. For second equation, the remaining term, that is 1 by r square, here 1 by r square into dou square t by dou phi square here. Okay, that is taken 1 by r square into dou square t by dou square. The third term, the remaining term, only single term, it is dou square t by dou z square here. Dou square t by dou z square is the only term remaining here. Okay, so that is the equation, and the common term d tau is taken here outside. So that is the A part of the equation we have completed. So the next part is B, that is heat generated within the element Q dash of G. Heat generated within the element is Q dash of T, which is termed as B part. As like in the previous derivation, we have taken Q dash of G equal to Qg into that volume into d tau, right? Qg, small letter Qg into that volume into d tau. Here the Qg is taken, and the volume here it is, the volume we taken Cartesian coordinate is dx dy dz. Okay, I will show you. Here Qg, for Cartesian coordinate we have taken Qg as small letter Qg into dx dy dz, that is the area, and d tau. For here we are taking the volume, that is the volume. We are taking the volume dr d5 into dz into rho, sorry, qg into dr d5 dz into d tau. Okay, that is simply b term. We are not derive it. We had taken. We can take the direct equation. We don't want to derive the b part and c part also. The increase in thermal energy, that is c part. The increase in thermal energy is termed as the volume, the mass into specific heat into temperature difference, that we have studied previous derivation. That is, yeah, the mass of the body into specific heat of the body into rising temperature, that is stored in the body. Mass is mass, density is equal to mass by volume. So mass is equal to density into, sorry, mass by volume, density is equal to, sorry, mass is equal to density into volume, and density is termed as here rho, and volume is dr d5 dz, and into specific heat capacity defined as C, and temperature difference is dou T by dou tau. Small, for a small distance we are taking dou tau, and into d tau, the term d tau. Okay, so we have completed A, B, and C. So now just we want to summate or make an equation that A plus B equal to C. We have A here, we have B here, and we have C here. Okay, so together by summation of the three equations, that is Q dash of G here, the B part, the C part, and A part. Okay, A plus B equal to C, right? So A part is K into dr into r d5 into dz into that term dou square T by dou r square plus 1 by r into dou T by dou r plus 1 by r square into dou square T by dou phi square. വായിക്കുമ്പോൾ ഭയങ്കര ടഫായി തോന്നുന്നു, ചെയ്യുമ്പോൾ അത്ര ടഫായി തോന്നുന്നില്ല, നിങ്ങൾ എഴുതി ചെയ്യണം. ഡോ സ്ക്വയർ ടി ബൈ ഡോ സ്ക്വയർ ഇൻറ്റു ഡി ടോ. ഓക്കെ, സോ പ്ലസ് this term qg into dr r d5 into dz the second term B part, that is A part, and equal to C. C is rho into dr d5 into dz into C equal to dot T by dot dt. Okay. By dividing the both sides by normally divide, we can cancel the common term, that is K into, so there is no K. The volume we can, for the 3 A and B and C, the common term is the volume. dr r d5 dz, here also dr r d5 dz, and also here dr r d5 dz. മനസ്സിലായോ എന്തിനാണ് നമ്മൾ പുറത്തേക്ക് ഓപ്പൺ ആയിട്ട് എടുത്തതെന്ന്? സിംപ്ലിഫൈ ചെയ്യാൻ വേണ്ടിയിട്ടാണ് പുറത്തേക്ക് എടുത്തത്. 3 ഡെറിവേഷനും സെയിം ഇതുപോലെയാണ് ചെയ്തത്. So the volume, net volume dr d5 dz, we are cancelling the 3 term dr d5 dz here and here and here. Okay, the remaining term will be k into this term, dou square t by dou r square plus 1 by r into dou t by dou r plus 1 by r square into dou square t by dou phi square plus this term plus qg. Qg is only term remaining here. Qg equal to rho into c into dou t by dot t by dot. Okay. Here d tau and d tau will also get cancelled. Sorry, I forgot to remind you that other than the volume, d tau is also common in the 3 equation. So d tau will also get cancelled. D tau here, and the equation will become like this. So this is the final equation. This is the general heat conduction equation, cylindrical coordinate. So let us simplify this equation into this, for including an element called alpha. That is not, I think I forgot to explain in the previous derivation. So for previous derivation, like we'll take the previous derivation. Okay, the final equation here we got is dou by dou x of kx dou t by dou z plus dou by dou y of ky into dou t by dou y plus dou by dou z of kz into dou t by dou z. This is the final equation we have got, plus qg equal to rho c into dou t by dou. Okay, for here there is kx, ky and kz. For a homogeneous material, like homogeneous material, isotropic material, we are taking the thermal conductivity as constant, that is kx equal to ky equal to kz equal to k. So here we are taking the 3 kx, ky, kz into a single term as k, only as thermal conductivity for homogeneous material. That is explained here. In the case of homogeneous material, property example density thermal isotropic, we are taking the kx equal to ky equal to kz equal to k. Kx equal to ky equal to kz equal to k, and together it become that. What will become when we take all the term as k? There is a common term. K will become common in the 3 equation. Here it is different. Kx is the, ky is a, kz is a. When we are taken as a k, the term k here, here will be a common term. We can take it outside, and we can derive this equation. Write this equation as, we are cancelling kx, ky, kz, as the equation become k into dou square t by dou y square plus dou square t by dou y square plus dou square t by dou z square equal to plus qg equal to this term, plus qg equal to rho c into rho t by dou tau. K is taken outside. Divide the whole equation by k. And here k will get cancelled, and here qg by k will arrive, and here also rho c by k into dou t by dou tau will arrive. Okay, divide the whole equation by k, and it will become like this: dou square t by dou y square plus dou square t by dou y square plus dou square t by dou z square plus qg by k equal to rho c by k into this. This is the final equation, right? So here we are introducing a term called alpha, which is referred as thermal diffusivity. Alpha is thermal diffusivity. It is termed as k by rho c. Here we have rho c by k, right? Here we have rho c by k, and by taking reciprocal, we will get k by rho c. That is the term alpha. which is termed as thermal conductivity divided by thermal capacity. Thermal conductivity is K, and thermal capacity is the multiplication of product of the rho into C. So to that, substitute alpha term. So K by rho C is termed as alpha. So here rho C by K will become 1 by alpha. So this is the final equation we want to get in the Cartesian coordinate. Dou square T by dou y square plus dou square T by dou y square plus dou square T by dou z square plus Qg by K equal to rho C by K, that is 1 by alpha into dou T by x. The alpha term is very important in the three derivation. That is simply rho C by K is termed as 1 by alpha. Okay. Here also by taking, here is the final equation we have got K into this term plus Qg into rho C into dou T by dou y dot o, and we are dividing the whole term divided by K. So here K get cancelled and it will become rho Qg by K and rho C by K into dou T by dot o. So here rho C by K is termed as 1 by alpha, right? So the final equation will become as dou square T by dou r square plus 1 by r into dou T by dou r plus 1 by r square into dou square T by dou phi square plus this term plus Qg by K equal to 1 by alpha into dou T by dou phi, where alpha is termed as thermal diffusivity. It is defined as thermal conductivity divided by thermal capacity. Okay, I think it is clear. So another thing I was forgot to explain last class is that the some theory is the larger the value of alpha, the faster will be the heat diffusivity. Thermal heat okay. So when the value of alpha is higher, the heat diffusivity, the heat faster it will diffuse through the material, and when it is decreases, the diffusivity will also decreases. Okay, and for we can change the Cartesian coordinate equation into three forms to get three equations. Just that we are, for the first, we are taking three cases. First case, the equation the equation is like that. Okay, the class is finished, right? Okay. Okay. So we can take attendance now. Okay. I think you have clear the equation derivation of cylindrical coordinate, right? This is general heat conduction equation of cylindrical coordinate. For next class, we are deriving the heat conduction equation for spherical coordinate as like that. Okay, just read by sending the PPT. Right? Okay, now taking measurements. Advait AK. Advait.
Present, sir.
Okay, Ajay Krishna.
Present, sir.
Akhil K. Akhil K. Is absent. Absent. Okay. Akshay Krishna.
Present, sir.
Akshay Krishna T.
Present, sir.
Okay, Akshay Rajivan.
Present, sir.
Amarnath P.
Present, sir.
Clint Frederick.
Present, sir.
Diljit Suresh. Diljit Suresh. Sorry, absent. He's present, right? Diljit? No.
Absent.
Okay.
Absent.
Google
Absent.
Google.
Present, sir.
Vishnu Dilip.
Present, sir.
Joel Tom.
Present, sir.
Junaid AP.
Present, sir.
Minosh K.
Present, sir.
Muhammad Sinan. Niket Mohanan. Muhammad Sinan is absent.
Present, sir.
Niket Mohanan. Pranav K.
Mohammed present.
Okay, right. Pranav K.
Present, sir.
Pranav
Present, sir.
N.
Present, sir.
Ritik M.
Present, sir.
Sharad KV.
Present, sir.
Srinath K. Srinath present. I think he's absent. Right? Srirag PV. Srirag PV.
Present, sir.
Sulabh P. Sulabh. Okay. Yadu Krishnan K.
Present, sir.
Yadul Harish.
Present, sir.
And Arun Raj.
Present, sir.
Vishnu KV.
Present, sir.
Vishnu Sajeevan.
Present, sir.
Neeraj K. Neeraj K.
Present, sir.
Ranish K. Ranish. It's absent. Okay. Vaishak C. Vaishak.
Present, sir.
Google Muralidhara.
Present, sir.
Okay.
Vaishak present.
Vaishak present. Okay, right. So, thank you